Hello and welcome to expressing in the form r cos x plus alpha and r sin x plus alpha. Okay? This is the first of the video in this theme showing you how it's actually done. Later on, if you look at some other videos I've done, I've got some examples of how you could answer questions, particularly those that are related to the real world. So let's just get on with this, how this is actually done. Well, first of all, why? Okay, and how it actually works. Do you know what the graph of cosine x and cosine and sine x actually look like? Okay, look like this. So sine x, cosine x. But have you considered what happens when you add the two together? Well, if you add the two together, you get this graph here. And of course, it's another sine wave or cosine wave. They're the same thing, just with the phase difference in angle. Okay. Of course, it's going to be slightly different in terms of the maximum value and minimum value because you're going to be adding together these values. Okay. But it does give us another sine graph, which means we can rewrite it in the form of something times sine x and then plus some angle because it's being shifted. Okay, basically this or this. Okay, you can either write it as a cosine or a sine, and that's why there are two different expressions that you can use for solving these problems. Okay, it's a sine graph. You can either write it as a cosine or a sine. Okay. If you worked out what that one actually was, it turns out to be this. Okay, maybe something you could do is, I'll just go back to that. At the end of this video, you come back to this bit, okay, if you remember, all right, and then just work out what that is in terms of this. Okay, and as a check, those are your two answers. Knock yourself out, do both of them. Okay, why not? Right, some actual examples on how to do it. Come on. Yes, at last. Okay. Some examples on how to do it in form r cos x plus alpha first using cosine. So I'm going to start off with this example. Okay. What I advise you to do is just go with it, and then if you want, just make notes later. All right. Or alternatively, you try and work it out yourself. But if you're watching this for the first time, I wouldn't advise it. This is just a watch and enjoy and learn moments first. Okay. So here we've got 8 cosine x minus 6 sine x, and you've got to write in form r cos x plus alpha. Right. The key to it is doing this. Okay, you need to be able to use the board, of course. There we go. You need to be able to. Let's put that up there. Use this identity first of all. Okay, use the identity. R cos x plus alpha is equal to this. That comes the identity cosine a plus b. Cosine a plus b is cos a cos b subtract sine a sine b. Okay, so r cos x plus alpha will be r cos x cos alpha minus sine x sine alpha. Okay, and what we need to do is write that in the form of this. So that there has got to be written in that form. That's why I've written this here like that, and we've got to be aware those two are the same. Okay, so those two are the same. And what you do is you match up this term with one of those ones, and it's good with that one because they've both got cosine x in it. So since they've got cosine x in it, the r cos alpha will be the same as 8. And then look at this one, they're both negative, so that will be exactly equal to that. So r sine alpha will be equal to 6, because the sine x is still the same. So the first thing we'll do is write down both of those, and you end up with two simultaneous equations, which you then got to solve. Okay? At first glance, they might look hard, but they're really, really easy. Okay? You can just use Pythagoras' theorem to solve the first one. Okay, and the reason is because of the identity cos squared alpha plus sine squared alpha. It's 1. Okay, so if you square that and square that, add them together, you get this is equal to 8 squared plus 6 squared. Because that is 1, you've just got r squared is equal to that plus that, which is 100. So r is just simply going to be 10. Right, so that's that done. Now you might think it would be a good idea to substitute r equals 10 back into this and then work out cosine. No, don't do that because it's a much quicker way. Instead, you can just divide that one by that one. Why in that order? Well, think about it. You should have done P2 by now. Okay, sine alpha over cos alpha is tan alpha. So using that identity, you can just do that, divide by that. The r's will cancel. Tan alpha is equal to 3 over 4, 6 over 8, 3 over 4. Inverse tan of 3 over 4. Okay, it's 36.9 degrees. And now we've got a value of r and we've got a value of alpha. We can just write in, final answer is that. I'm slightly regretting my choice of media to present this, okay, but I'm going to keep on going, okay. Basically, I've got it on PowerPoint. I'm not going to put all that onto another interactive whiteboard. So 10 cosine x plus 36.9 degrees. Okay, good. Right, next example. This one there. Notice how similar it is to the previous one. Okay, this one says negative 8 cos x plus 6x equals, well, you've got to write in form r cos x plus alpha. So the first step, as with before, you just want to write out the identity. It's going to be this, okay? So r cos x plus alpha is equal to r cos x cos alpha minus sin x sin alpha, okay? And then put the two pairs together. So that's going to be cos x and cos x, so negative 8 is r cos alpha. And that's plus this time, that's minus, okay? So that's going to be r sin alpha is negative 6, okay? You all right with that? So you've got r sin alpha is negative 6 and r cos alpha is negative 8. Okay. Same as before, you just work out what r is. Now I can just skip the cos squared plus sine squared bit and just get straight to r squared is 8 squared plus 6 squared. R equals 10, as with before, of course, because they're the same numbers. Now if you do the inverse tan of 8 over 6, you'll get 36.9 degrees again. Okay, but that can't possibly be the right angle because it's a different expression. Okay, how can you have a different expression but have exactly the same result before? You can't. Okay, actually, the required angle is going to be negative 143.1 degrees. You've got to subtract 108 degrees. Okay, why is that? Why? Well, I'm going to show you why that is. Okay, so my next bit is on how do you determine the required angle. The short answer to that is the Edexcel course makes it really easy for you. It kind of takes the fun out of actually doing it. Okay, they actually guide you through it and they basically make sure that the angle is acute and between 0 and 90 degrees. Yeah. I suppose they don't give you the angle. How do you actually do it? So remember the circle, because these are circular functions. So here the r stands for the radius in this particular case. So a general point on the circle is there, and that has got coordinate points r cos alpha, because that's r and that's the adjacent there. So the coordinate point is r cos alpha, r sin alpha, because the value of b is going to be r sin alpha, it's opposite alpha. Okay, so glad you're happy with that. So what that means is, generally speaking, the a there stands for the x coordinate, the b stands for the y coordinate, and the coordinates could be in this quadrant, this quadrant, this quadrant, or this quadrant. Here's my bit of colour coding. Okay? If they all are in that quadrant there, that means both a and b as coordinates are positive. Okay, so the a coordinate, b coordinate is positive. If they're both positive, that means that is positive and that is positive, and the angle then is between 0 and 90 degrees. Okay. If, however, you've got this case here, it lies in this quadrant because a is negative and b is positive. So notice if a is negative, b is positive, then the angle must be between 90 and 180 degrees. It must be. Okay, so if I have a line drawn in there, then the angle between there and there is going to be between 90 and 180 degrees. Okay, see where I'm going with this? Good. Next one, if a and b are both negative, it's down here. So negative a, negative b, down here. The angle then is going to be between 180 and 270, or between negative 180 and negative 90. Because remember, positive angles that way, or, whoops, negative angles that way. So negative 90, negative 180. Or alternatively, in this quadrant here, that is when you've got a is positive, b is negative. So a, negative b. So somewhere between negative 90 and 0. Okay, let's just go back to this one. So here, what have we got? We've got both of these are negative. Okay, so you've got negative a, sorry, a is negative and b is negative. Remember, the a stands for the cosine value because it's adjacent. Okay, cosine across, cos across, or some people like to say. And sine is the vertical value. Okay, what's a good one for that? I don't know. It's a sine, and you look up for a sine. So best I can do on the top of my head. Oh, top of my head, another vertical one. Yeah, so they're both negative. So that means that it's going to lie somewhere in the third quadrant, bottom left-hand quadrant. So that's how we know the angles between negative 180 and negative 90. So you just do that, subtract 180. Okay. Moving on. Let's have a look. What am I doing? What am I doing? What am I doing? Yeah. Let's have a look at some of these ones. Expressing in the form r sin x plus alpha. Okay. You recognise that? Exactly the same as one we did before. Only before we did it in the form r cos x plus alpha. I just want to show you the similarities between them. Okay, that's why I'm choosing very, very similar examples. If you work through these four, you'll see how they relate to each other. So, as with before, you do exactly the same thing, except the identity is going to be r sine x plus alpha this time. So sine x plus alpha, sine x cos alpha, plus cos x sine alpha, all times by r, of course, and you just want to equate those two together. So get the sine x terms, that and that, whoops, yeah, that and that. So that means r cos alpha is going to be equal to negative 6. And then the cos x terms, that and that. So r sine alpha is equal to 8. So there they are. R sine alpha, 8. R cos alpha is negative 6. Pythagoras' theorem again. Whether they're negative or positive makes no difference, of course, with Pythagoras' theorem. Another thing about Pythagoras' theorem, yeah, look, in terms of the circle, remember r stands for radius of the circle. Okay, so those are just lengths, hence why the actual positive negative doesn't make a difference with using that. R is 10, as with before, and if you do that divided by that, you get tan alpha is negative 8 over 3. I'll try it again. Negative 8 over 6. 8 over negative 6 technically, but yeah, negative 8 over 6, negative 4/3, and inverse tan of that is negative 53.1 degrees. Then you've just got to consider, is that the required angle? Well, I've kind of given it away there, haven't I? No, because I really am regretting my PowerPoint move, because this is just all over the place. If you don't see many more PowerPoint features in my future videos, don't be surprised, because this is a little bit fiddly. Okay. So you've got negative 53.1 when you do the inverse tan of negative 4/3, but consider where it lies, negative 6, 8, here it is, so negative 6, it lies up there, okay, so you want an angle here between 90 and 180, okay, so you want an angle between 90 and 180, and that's all it, so just add on 180, and you get your angle that's required, okay, so you're I'm going to try and keep calm with my PowerPoint. Your answer is this, 10 sine x plus 126.9 degrees. Okay, and next one, here we go. Very similar again to example 2 this was. So first steps, I mean maybe I can just skim over this because it's just exactly the same as before. You've got the identity again, r sine x plus alpha, set that equal to this. So here you've got the sine x and the sine x terms, so r cos alpha is equal to 6, and the cosine x terms, so r sine alpha is equal to negative 8. There we go. R again is going to be, you guessed it, 10. There we go. And this time, sine alpha over cos alpha, negative 8 over 6. It's going to be as before, because we had a similar fraction before, didn't we? Negative, no, same fraction before, negative 4/3. Okay, and it's the required angle this time. Why is it the required angle? I love my PowerPoint. I really love my PowerPoint. It's not making me upset at all. Okay, why is that the required angle? Well, look, A is 6, B is negative 8, and I see where it goes. 6, negative 8, somewhere down there. Okay, if it's down there, it's between negative 90 and 0. So that is fine. It's between negative 90 and 0. So it is the required angle. Okay, and so therefore that's my value. Okay, 10 sine x minus 53.1 degrees. Okay, hope that was helpful for you. Okay, here's an example of how you can use this to solve an equation while I've just got some time and while it's actually on there. So here we go. Solve that equation there. Okay. First of all, choose whether you put in the form r cos x plus alpha or r sine x plus alpha. Okay, so this one here, which one is it? I honestly can't remember. Oh, there we go. It's 10 cosine x plus 36.5. Work through that just to make sure that you're happy with it, okay? Or just go back to the example where I showed it, okay? But earlier we had it as 10 cos x plus 36.9 equals 5, okay? You can solve that. Divide by 10. Inverse cosine of 0.5, okay? You get two possible answers in the domain which you need, in the interval that you need, okay? So inverse cosine of half is 60 degrees or 300 degrees. Subtract 36.9 from both of those, get your answers. I'll show you how it works with the sine one. So earlier we had 10 sine x plus 126.9 is equal to 5. Divide by 10 again, you get this. Inverse sine of 0.5, this time it's 30 or 150 or 390. Because you've got to subtract 126.9, when you do 30, subtract that, you don't get an answer in the required interval. That's why I've gone for 150 and 390 as another 2. Okay. Then when you subtract 126.9 from those, you get, of course, the same answers as before. So, like the simple example showing you how to solve an equation. Okay. That's what that looks like on the graph, incidentally. Okay. So the graph of 8 cosine x minus 6 sine x, okay, and the line y equals 5, you've got your 2 possible answers there. Just verifying for you what those actually mean in real terms. Okay. I'm hoping that was fine for you. I did rush it a little bit because I had so much to get through, but the advantage of a video is you can always play bits back and just hear bits again. Okay. Thank you for watching and hope to see you again soon. Bye bye.